also but basically agenda. First, we'll be going through the optimistic oracle, what it is, and why we think it's important. Also touch a little bit on the DVM. We'll then go into kind of the basic flow of how the optimistic oracle works and also how the DVM works. We'll talk a little bit about a new upcoming flavor of the optimistic oracle and how that's different than the current one that we have today and why we created that. And then we'll talk, we'll talk about basically polymarket, how you can propose, how like users interact with the oracle, and then we'll also talk about the dreaded yes or no query, which is what all of these very intense disputes have been about recently. Yeah, and then we'll leave some, this is more like discussion time at the end. So UMA's optimistic oracle is generally just a method to securely bring any piece of deterministic data on chain. So there's an oracle problem in blockchain where it's a challenge to kind of bring off-chain data on chain, and there's questions around like who has the authorization to do that, and how do you do that securely, because contracts on Ethereum are self-executing, and once you bring that data on chain, things will happen, and it's important that it's done in a truthful manner. Optimistic oracle is basically a generalized escalation game. So more traditionally, oracles are kind of about providing this like service where it's like, our oracle is like, we will provide you the ETHUSD price or whatever. The optimistic oracle is more of like a framework for how an oracle can function. So it's a generalized escalation game where basically anybody can participate. There are not a permission set of parties that can push these prices, but anybody can request pre-approved types of prices or pieces of data. Anyone can also propose what the value of those requests should be. And then we'll get deeper into this, but like after that proposal happens, there's basically like a review period, and anybody can also dispute those values. So ultimately, like, the thing that backs all of this and secures all of this is something that we call the data verification mechanism, our DVM. This is our UMA token holder voting system where UMA token holders can opine on and ultimately resolve what disputed prices should have been. I think I heard somebody gonna say something. Guess not. So today, UMA's OO can provide data on Arbitrum, Optimism, Boba, XDAI, Polygon, and Mainnet, with Avalanche soon to follow. So, the idea is that we can be an integration and a core piece of infrastructure for financial and Web3 dApps on all of these different networks. Today, the OO, because it's generalized and can really serve any piece of kind of deterministic information, or not even deterministic isn't a great word, but we'll discuss that later. But can provide, very generalized types of information. It's used for a lot of different use cases. First, that people are probably most familiar with is the OO is used by Polymarket, which is informations market or betting market platform, where people can bet on binary markets. An example of a binary market might be, like who won the basketball game last night, or like who won the Super Bowl this year. And so people will basically buy like synthetic tokens representing one side of the bet ahead of time. And at the end, when the market outcome is known, or sometimes even when it's not known, Polymarket will basically submit this plain text question to the optimistic oracle. So it'll be like, who won the Super Bowl in 2022 or 2000? Yeah, it's 22 this year, right? Yeah. And anybody can kind of read that question and say, I know that, I can Google that, and we'll respond with that, with the answer to that question. A lot of times, as we're seeing now, there's like ambiguities with those questions, and then sometimes they can go up to a dispute and like more discussion. But basically, the theme here is like you allow for flexibility in question definition, because proposers should be basically financially incentivized to answer whatever is like the most obvious answer. So it's very easy to answer something like, who won the Super Bowl? And it's very easy for everybody else to kind of come to the same conclusion that I did. We're also used by, this probably isn't a great one to talk about, but different synthetics platforms. So Yam Synths, something that provided different kind of very unique financial products, things that you wouldn't see in other places in DeFi. So a couple examples of this would be like, they created synthetics on basically what like the 30-day median gas price was on Ethereum. And those were expiring synthetics built on our EMP contracts. And basically the way that like those synthetics would ultimately be priced and worth like some amount of collateral at the end of their life cycle would be, they would request our optimistic oracle and be like, hey, what was the 30-day median gas price over the previous month? There's also kind of less structured things where there like aren't necessarily like set prices or pieces of data that are being requested, but more like generalized dispute resolution. So this logo is for Sherlock Protocol, which is an insurance protocol in DeFi. Sherlock provides smart contract insurance. So like people can purchase, if they're like a big user of some kind of like new protocol or existing protocol in DeFi, they can purchase like different types of insurance on Sherlock. And if there is a smart contract hack and they lost funds while using that other protocol, basically Sherlock LPs would pay back these people. Sherlock, kind of as traditional insurance markets do, they have these like insurance agreements where like protocols when they sign up and like these insurance whatever tokens, or I forget what they are issued. There's basically an insurance agreement that like outlines the types of things that Sherlock covers. As people know, like kind of insurance claims in the traditional world like go up to dispute all the time. They go to courts because it isn't like always clear what like these plain text legal agreements cover. The same will probably be true here. So like Sherlock functions in a way where when a hack happens on one of their covered protocols, that protocol can then request a payout and say, hey, I got hacked in X way and I'm owed X amount of money. Sherlock then kind of has like a delegated committee of like security experts that then decide if that claim is valid and if LPs on the Sherlock platform should pay out. If they decide no, basically these protocols can then dispute that and say, I disagree with this. I think like you guys are not answering honestly here. Like this should be covered. And at that time, it would go to UMA's DVM to kind of resolve the outcome. And the idea is that UMA's DVM does not really have skin in this game. and would be more of an impartial set of voters and could, assess this objectively. Any questions or comments? I know there isn't a lot of structure to this, but
have we ever had this shadow lock dispute?
we have not. They are definitely designed to be very, very rare. It's like UMA is playing kind of the role of the Supreme Court in the Sherlock dispute case. So how does the optimistic oracle work? This diagram is on our doc site. It's a little hectic, but we'll try to talk through it today. Basically, there are pre-approved types of prices, like I talked about before. I probably should have had a slide for this, but maybe not types of prices, but types of methodologies for how to arrive at a price. So we use these things called UMIPs, which stand for UMA Improvement Proposals, to approve different types of price identifiers. They're also used for other things like protocol upgrades and approving different types of collateral currencies. But we also use them to approve price identifiers. Now, a price identifier is essentially just a methodology on how to arrive at a price. So all that is literally the only thing that is approved on chain is just kind of like the plain text name of that price identifier. So you can say like, oh, I want to add like an ETH USD price feed to UMA, but really all you're adding on chain is just registering this name of the ETH USD price identifier. But within the UMIP defines how you should arrive at like your answer to a price request, and also how price requests should be structured. So we also use, I guess, on the side of like how price requests should be structured. One thing that is always covered in UMIPs is ancillary data format. So like I was talking about, like all that is kind of stored on chain, and all like the first thing you're submitting when you're requesting a price from the optimistic oracle is just saying like, hey, I want the ETH USD price at like this timestamp. That used to be like kind of all UMA could do. Basically, like all of kind of the logic needed to be baked into the UMIP off chain. I think maybe like a year ago now, we came up with this concept of ancillary data, which is just kind of like a blob of data that you can also pass in along with your price request. And you're basically like passing additional parameters in with like your high level price request. So an example would be, I'm requesting like the ETH USD price at, at 12 p.m. today, but I also pass in parameters related to, say, like the exchanges that should be used, the markets that should be looked at, and maybe like the TWAP length that you should calculate this ETH USD price with. With the yes or no queries, so like with these prediction market things, literally all that is approved is kind of this yes or no query name for this price identifier, which implies that like people need to ask questions that kind of have yes, no, or indeterminate outcomes. But all of the questions themselves are kind of housed in ancillary data. So people just kind of write them down in plain text and pass that along with like their price request. Yeah, that was a little bit of yeah, I guess that wasn't what we were supposed to be talking about on this slide, but yeah, things get kicked off with a price request, somebody asking a question. And then because there's that UMIP, there's basically UMIPs are not kind of law, right? But like because they're defined, it's like the most obvious way that people should answer these questions. Um, so then basically after somebody asks a question, uh, they'll also usually be paying a reward along with that like data request. And so proposers in the system are basically incentivized to answer that question because they want to get that reward. So they'll look at the question, they'll kind of off chain determine what the answer to that question should be. And then they will post that answer on chain along with a bond. So a bond is essentially just this proposer needs to have some sort of financial risk at stake. Because if they don't, then basically there would be no cost to this proposer trying to propose incorrect answers to somebody's question. And, you know, it would basically be like free except for gas costs for somebody to try to manipulate what the outcome of optimistic oracle requests should be. So once a proposer answers the question, there's something that happens that we call a liveness period. Um, a liveness period is basically just a delay between between an answer being proposed and an answer being accepted as truth. Uh, and this is really why we call our oracle an optimistic oracle. Kind of the same sort of concepts are used by other things in the blockchain ecosystem that are also named optimistic, like optimistic rollups. But during that review period, everybody can see what that proposer's answer was, and they can look at the UMIP and look at the price request themselves and calculate independently what they think the answer should be. And if it disagrees with what the proposed answer was, they are free to dispute that proposed answer. So this disputer, kind of, we're here now. Basically, if it's not disputed during that liveness time, then the optimistic oracle accepts that this answer is true and you know, allows people to use that answer now. So like this person that was originally asking the question or contract or whatever could use that answer. If it is disputed, then of course, like we do not accept it as truth yet because it's not clear, like, you know, which answer is correct. So this disputer is also post a bond for the same kind of reasons, like they need to have some sort of financial risk at play. Also, sorry, there's a lot to get into here, but if an answer is accepted, then this proposer basically receives the original reward that was provided by the requester, as well as their bond back. So they were correct in our system, so they didn't lose any money and they received the reward for basically doing the work to answer this question. But if it was disputed, then the disputer also posts a bond, does not post their own answer. They basically just say, you know, I think this answer is incorrect. And then once that dispute is filed, kind of that thing then goes to our DVM. And we have a voting cycle like we're having now, where the proposer and the disputer and everybody else in the UMA system or elsewhere can basically discuss and also independently calculate what they think the answer should have been, and then try to arrive at a conclusion and vote on what that conclusion should be. Any questions? Cool. So this is just a really rough summary of what we were just talking about, but basically general overview of what the flow looks like. There's a price request, a proposal in response to that request that then sits through a liveness period, sits through a review period. If it's not accepted, if it's not disputed, it's accepted as truth. If it is disputed, then it's escalated to our DVM. And this is why I said earlier that, the optimistic oracle is really just like a generalized escalation game, because we provide the framework for this process to happen, but people can kind of request very generalized types of prices, and like people can also propose whatever they want in response to those prices, but everybody basically is like economically incentivized to act honestly in this system, because if they don't, the assumption is they will be caught, and ultimately the DVM will decide who was actually acting honestly, and that person will be financially rewarded while the other person loses out. Anything else worth talking about here? I don't think so. This slide is pretty unfinished, but one thing that's in development right now, and I believe is in the next audit, Matt or somebody on the engineering, correct me if I'm wrong there, but we're going to have basically a new flavor of the OO that's different in, pretty small ways, pretty nuanced ways, but it is different, so it's worth talking about. Basically with Polymarket, kind of realized that like our Oracle system today is not great with like, markets that do not have kind of like a predetermined like XFree timestamp. So we have these things now that, we call like early XFree markets or early XFree price requests, where there are kind of like two pieces of data that are not known beforehand. There's like what the price or what like the outcome should be, and then also like it's also not known like when that outcome should be requested or proposed. So I think a good example of that is the dispute we're having right now, where it was generally asking about if this chess player would be banned from this tournament that was happening in a few months. Kind of that question implies, it like there's no set time that he could be banned at. You could kind of pick an arbitrary date like far in the future and say like, oh, we'll decide then. But if you kind of want like speed of like settlement, you also kind of need to allow for this request to happen at any time. So that's called an early XFree, where basically when the requester is requesting this price, the assumption is that they're doing it because they think that kind of the outcome is known now, or the condition of the early XFree has been met, and so they request it, and then like the proposer is able to determine what the outcome is because like that market is resolvable. We'll talk more about that later on in the yes or no query example, but yeah, there's also situations where like the proposer can basically answer the requester and say like, oh, you're actually like requesting this market too early, and we'll answer what we call like a magic number, which is just our way of saying, this market is not yet settleable. Like I'm not able to determine the answer to this market, not because, like the events happened and, or like the question is too ambiguous and I have no idea how to answer this, but simply because like it hasn't happened yet. Like if you were requesting the outcome of the Super Bowl 2 weeks before the Super Bowl happened. So the way that the new flavor of the optimistic oracle works, and hopefully I get this right because it is new and still, I think, partially in design, but basically right now requesters will only request kind of at the time that they want the data. So all proposals and all like DVM discussions center around, a request at a specific timestamp for a price identifier. So you're always using the request timestamp, and that's what you're like answering the price for. This kind of turns that idea on its head, and instead, like requests are like registered or made basically like whenever, like immediately at the time of like market creation in the case of Polymarket. So they would create these markets and then immediately like register it that like at some point in the future they want the answer to this question. Proposers would then be able to view, a super long registry of kind of all of these different like markets that are out there, and would essentially be like assessing, is this market resolvable at this point? And if so, like what is the answer? And proposers could answer at any point. What is the point I'm making? Oh, one thing is like, I'm not sure if this logic is actually like in the new optimistic Oracle contract, or if it would be based upon kind of like contracts that use this, like, performing some sort of logic when using like the callback from kind of like getting the price. But like the idea here is that it would never be a correct answer for a proposer to answer, this market was requested too early, because we're no longer caring about like the request timestamp. We're only caring about the proposal timestamp. So if the proposer was answering the magic number, they're automatically wrong, right? Like the only valid answers are, in the case of Polymarket, yes, no, or, this market is broken. So I'm going to answer kind of 0.5 or indeterminate. There are also there's some like other slight differences, but I don't think they're necessarily worth getting into today. Yeah, so at a high level, we talked about what the DVM is, right? The DVM is kind of the ultimate security layer, that the ultimate resolution layer that kind of secures the optimistic Oracle, right? The voting process that we're voting in right now is the DVM at work. So the DVM is basically just, anybody that holds UMA tokens can vote over this like 2-day voting period, and basically like propose what they think the answer would be. And then at the end of the voting period, basically all of those votes are tallied up and weighted by the amount of UMA tokens that you hold. And that's like kind of how these disputes are settled. And like the winning number, like the winning vote is whatever the majority vote would be. So it doesn't have to be 51%. It's just whatever the largest percent vote is, as long as, actually, I'm not sure what the answer, what is correct here, but is it as long as the majority vote is over the GAT, or just like the total voter participation?
So yeah, this is where like some of the median vote stuff that I've seen a little bit of chat about starts to matter. The way the logic works, and I do want to double check what I'm saying here after this call, and I'll correct if I'm wrong, but the way that I believe this works is that the majority vote, if over the GAT, if it's if not, like let's say the GAT is 5%, if fewer than 5% of tokens participate in the vote, then the result, like no result is published. We just roll the vote and try it again. There's another condition that is less well known, where we also roll the vote. And that is when the modal outcome, meaning the outcome, if there's no outcome that reaches 50% of the votes, if no outcome reaches 50% or greater, there is the mode and the median would not be equal. If there is an outcome that reaches 50%, then the mode and the median would be equal. If no outcome reaches that 50%, then we also roll the vote. So this means that in the original proposed, like Vitalik's proposed Schelling point oracle system, he proposes a median system. Medians are really hard to compute on chain, but this means that our oracle always would produce the same result as that oracle. And if it doesn't produce the same result as that oracle, we just roll the vote. So I think something that people tend to focus on a lot is like the fact that we don't do this median, and we say in our white paper that we should, but it actually in reality makes we effectively end up with the same outcomes.
That is really interesting and not something I know. Thank you, Matt. I guess like Matt was talking about, our DVM idea was originally based off of like a Schelling point voting system paper that Vitalik published a long time ago. I forget when, 2017 maybe. And the idea of a Schelling point is basically, what's the best way to define this? A Schelling point is like a point of congregation. No, it's not the best word, but like it's the idea that like people will vote for or do whatever is kind of the most obvious if they're acting independently. So as long as they're not colluding, people will do whatever is the most obvious. So like I think the common example is like, if you told two people to meet on a certain day in New York City, but didn't tell them like where or what time, then most people would say like the most obvious thing to do is go to say like Times Square at like 12 noon, or Grand Central Station at 12 noon. Here, for the voting system, the idea is that like people are acting independently, and they're financially incentivized to kind of vote for the most obvious thing because they receive rewards if they are correct. Then people will act honestly. They will read the price request and assess it, and basically congregate around whatever the most obvious outcome would be. And that's like part of the reason why we have UMIPs. Like I said earlier, like UMIPs are not kind of law. Like you do not always have to follow them. But UMIPs provide a Schelling point because they provide kind of a methodology that like kind of UMA voters have approved as like this is probably like the methodology we will use to answer like these types of price requests. Also, there's been a lot of interesting discussion in the general channel about just like, are we acting like a Schelling point over the last day or so? Because like, when people do start to collude or start to, follow what people say in the voting channel, and are not kind of determining these things independently, it becomes like less of a Schelling point, at least in my opinion. I guess one other thing to like very briefly cover. One other thing to briefly cover is, so Britt asked a question about this yesterday in No Stupid Questions, so I'm sure there's good answers there as well. But like something that especially new people probably have heard a lot but don't like fully understand is this like profit from corruption, cost of corruption, inequality. So we say that, using the UMA DVM gives you kind of economic guarantees that you will receive the correct answer, that you will, like people in the system will always act honestly within that Schelling point system. Basically, the way this works is the idea is that we should always have this inequality, and PFC stands for profit from corruption, and profit from corruption is basically like the maximum amount of value that like somebody could steal from like a contract or a system using our Oracle solution if they manipulated the price. So if they could somehow corrupt that price that was being returned. So like in a polymarket prediction market, the profit from corruption would be if like all the shares are kind of trading at like a yes outcome right now, but you hold all of the no shares. The profit from corruption would be like the total amount of like value in that market, or like the total amount of no shares that you hold. Because if you corrupted the price and flipped it to a no vote like incorrectly, that's how much money you would gain. We often kind of talk about the PFC, or like our total PFC, as the same as like our total value secured. There's definitely a lot of nuance there that like Chase especially likes to get into. But yeah, the idea is this is supposed to always be larger, or sorry, this should actually be flipped, right? This should always be smaller than the cost of corruption. So in our system, to win a vote, you need to kind of have more than 50% of UMA tokens vote with you, UMA voting tokens vote with you. So the cost of corruption is simply like the amount that it would take to either bribe or purchase enough UMA tokens to kind of vote dishonestly in a DVM price request. So if we always kind of maintain that like our market cap divided by 2 is larger than like the total value that we're securing, then, and again, a ton of nuance here, then we can say we're economically secure, right? Like we are providing X amount of like economic security. Because yeah, I don't know if I explained that very well, but other kind of like mechanisms within the DVM, basically if you vote with the majority, if you vote correctly, there are inflation rewards paid out. So these are the rewards you claim in the voting DApp. Inflation rewards are 0.05% of the total network token supply, distributed pro rata by stake to the winning vote. Yeah, so that probably sounds pretty confusing, but it's basically like a very small, basically new UMA tokens are minted. It's a very small amount compared to kind of like our $105 million UMA tokens in circulation right now, or whatever it is, but that is distributed to all of the winning voters. So if you are kind of trying to get more UMA tokens, your economic incentive is to get more UMA tokens, then you want to vote with the majority, and we'll follow this Schelling point. Within the dispute, like we were talking about earlier here, I only included this because like this is something that comes up a lot in Discord, but basically there are 2 parties in the dispute, right? There's the original proposer and there's the disputer. Both of them have provided bonds and also something else called a final fee, which is basically like a spam prevention mechanism. Once kind of the outcome of the dispute is published, we now know who won. If the outcome does not agree with the proposed value, then the disputer won. If it does agree, then the proposer won. And the winning party will receive their own bonds back, plus their own final fee, plus 50% of the loser's bonds. And I believe this is like adjustable by vote in our system, plus whatever the voting reward was. The UMA system, or our UMA store contract, will basically get the loser's final fee. Sorry, this should be the loser's final fee plus half of the loser's bond. Taking a lot longer than I expected, and I do want to leave like more time for discussion. But like that was the DVM at a high level. I think like really high level, really quickly. Like Polymarket has presented interesting challenges for our optimistic Oracle system because these are kind of plain text things that you need that human element, which is awesome because that's not something you can kind of get in other Oracle systems, but you need that human element to answer these questions because they are just like plain text questions. Polymarket requests, 30 to 50 kind of market resolutions every day. And all of those kind of need eyes on them. They need eyes to A, answer these questions, and B, probably more importantly, kind of view the answers of other people and make sure that those are correct. So like a big focus kind of last few months has been kind of hardening the OO verification process. So there's like, various parts of infrastructure that have been built to kind of check, to automatically, check or kind of with some assumptions check to make sure that like proposed prices like agree with kind of prediction markets that are out there like Polymarket. There's also like a decentralized kind of verification program where any superhuman can come in and kind of like provide evidence once a proposal is made in the form of just like screenshots, and they'll receive like a small reward in UMA for that. So, and we also kind of have like a full-time verification team that provides like 24-hour coverage of markets being proposed, and we'll like verify these things. These are both like present in Discord, so if you're interested in like kind of seeing these things in action, like go check out those channels. Also, like another cool trend we've seen is that obviously like the people that use these prediction markets are like they're the most invested parties in them, and we've seen like a ton of kind of partner protocols, and like especially like the Polymarket community become very actively involved in the proposals of these prices as well as like the verification. So kind of this gap illustrates a lot of what we talked about today, like the process, and probably is what I should have used to like do this presentation, but this is a DApp that we recently released specifically for people to interact with the optimistic Oracle in like a really easy way. So you cannot submit like new price requests to this DApp, but you can do everything else, and everything else is answering questions. So proposing, viewing those questions, and also ultimately like disputing answers that have already been proposed. So I won't go through this too much, but like, important things here. Like we talked about like the bond. So this is like the risk I would have to be willing to put up if I wanted to answer this question. So here it's like 11,500 USDC. talked about the reward. So like this is the reward I would receive if I proposed an outcome and it was true. It was accepted as truth and nobody disputed me. We also talked about ancillary data, or in this case, kind of like the yes or no question that is being asked. So when you're proposing an answer, really what you're doing is you're looking at this yes or no question and trying to answer that in kind of the most obvious or correct way possible. You can't answer with like yes, no, or maybe. So there's like kind of a set format where like different answers are kind of set to like different numbers. So when you see like notifications in Slack about, like optimistic Oracle requests or optimistic Oracle proposals, really what that means is like behind the scenes, like a human is coming in here, reading this question and saying what they think the answer should be. So like Googling what the answer to this question is, and then saying what they think the answer should be. Also like very related, but like once those values are proposed, you can also kind of see those previously proposed things. And this has already been disputed, so I cannot dispute it. But I would also be able to kind of see what my bond would be if I wanted to be a disputer and dispute outcomes that are currently in that review period. Yeah, and then just because this is like kind of good to know for today's vote, for yes or no queries, there are 4 possible outcomes. There are questions about this in Slack yesterday. Usually the outcomes are yes, where you would vote like 1, just the value 1 in the voter DApp or in the optimistic Oracle DApp. It's also no, obviously, and you would vote 0 for that. Then kind of like the more complicated portion is like, what is the difference between 0.5 and this crazy number? 0.5 is basically you're answering that like the answer to a question cannot be determined, but you also know that like the answer will not be able to be determined in the future. So if a yes or no question is asking, if, who won this basketball game yesterday, but the basketball game really ended in a tie, then you could answer 0.5. Or if somebody asked a question that was just like nonsense and like literally made no sense at all, then you could also answer 0.5. That's in contrast to this magic number, which is like, we cannot confidently answer this question today, but think that it will be answerable in the future. So you're basically answering that, this price request was made too early. Yeah. I know that was like very unstructured, but I was trying to cover a lot of different things, but I don't know. Anything anybody wants to discuss, especially kind of around like the DBM voting process and stuff that's happening today, or just like any questions?
Thanks for this presentation, Sean. The question that I find myself asking in the last 2 disputes is essentially around how strict we want to be with the quote unquote rules. Essentially, somewhat in both cases, there was rules that sort of might prompt us to say this question is unintelligible. We might just say like there isn't these rules make the question like impossible to follow the rules and answer it. So we could be sort of strict and respond that way. But in this is a dangerous word, but in the spirit of the questions, like and the way I say this is if my mom asked me this question, was this guy removed from the chess tournament and was the COVID rates under 25K last month? Like I know what I would tell her. and so I feel like there's this like ethos or something that we're setting. I realize this is actually a really big question. I'm just curious, like, I don't know, curious what you think of that prompt, Sean.
Yeah, it is a really big question. Like without thinking about like precedents that we're setting or whatever, uh, like if you think about kind of the DVM process as like a Schelling point, then like I agree. Like it's possible that some people might arrive at the outcome that like these questions are unintelligible and like we should not be answering them for the last two disputes. But I also think that like that was not the most obvious outcome from like reading these things. Like from the discussion in the voting channel, you know, people felt like very strongly in like different ways about like kind of what the outcome should be, and thought that it was like obvious that like their answer was true, right? And like I feel the same way when I look at these questions. It's like yes, like there is like room for interpretation in a different way, but like when I read this, I think there is like an obvious yes or no answer here. I don't think that's always going to be true, right? Like if they just put in like if half the question was like random letters or whatever, or like yesterday we had a proposal for a question that asked like uh you know who won the Lakers versus Nuggets game, but then it was like if the Rockets won, answer one, and if the Wizards won, answer no, and it was like I have no idea how to answer, right? That is completely broken. So that like there it is obviously kind of indeterminate. So I think if you like kind of fall back to like the Schelling point theme where like people should be assessing these things independently and voting whatever is most obvious, then we don't really have to think about like precedents and we should assess everything kind of case by case.
I like that answer. Thanks.
Thanks.
This may be a mute point, but with some of the stuff that's going through the audit just now. But one of the things that I've noticed in the Discord voting channel is people putting up numbers that are very close to, but not identical to, the magic number. And it's a bit difficult to find it sometimes, and people aren't always aware that it exists for early expiry.
It's a great comment. So right after this call, I will post in Clayton's new Discord channel and just pin what the potential correct answer should be. Thanks, Fari. Cool.
Cool.
Real quick, sorry. This change where a market creation is simultaneously a request. That's what you said earlier, right? When a market's created, it's immediately requested.
I guess from like the optimistic oracle's perspective, it's like that doesn't have to be true, right? But it's just like it can be requested before it's ready to be answered. But yeah, like that's how I guess we're thinking like, you know, polymarket would work.
Right. And that's just a procedural change, not a technical one.
No, it's a technical change.
Is it? Okay. Because previously the request marked the moment that they were looking for the data, but now it's not that way anymore.
Yeah. So like we always vote on like request timestamps, right?
Right.
And not proposal timestamps. It's also other technical changes that are kind of very related, but also not worth getting into. Like how do you pay out kind of like rewards that are associated with like price requests? in that kind of situation. Like, how do you allow people to enforce that, like, only like certain answers can be answered, and like automatically reject things like the magic number? Yeah.
Cool. Thanks.
Great. Thank you, Ari, and everybody else.
Thank you, Sean, for
Very
stepping
nice.
in.
Very helpful.
Thank you, Sean.
Thanks, Sean.
Oh.
Yeah, Chase, keep going.
Bye.